In the previous section, we have discussed about the unit step response of the system, and in that lecture, we have already discussed about that. If we have impulse response of the system hk, then their summation where k is moving from minus infinite to n provide the step response. And if we have step response Sn, then their first difference, which is nothing but Sn minus 1, provide the impulse response of the system. Similar for the continuous time, if we have impulse response, then their summation integral, which is moving from limiting from minus infinite to t, provide the step response. And reverse, if we differentiate this step response, then we get impulse response of the system. Now we are moving one question based on this. The question asking for the response of the DT-LTI system for the step response is given. Step response is given is 2, 4. Then find the response of the system for the input which is given as 1, 3. Okay. Then we have a question which have if step input is applied to the system, then output is 2, 4, and the question asking for if we have input 1, 3, then what is the output? Okay, then we know that the output of the system is nothing but impulse response of the system convolve with input of the system. And here we have input, but in case of impulse response we have step response. But we know one formula, which is impulse response is equal to Sn minus Sn minus 1. Okay, then we have Sn equal to 2, 4 here, and Sn minus 1 is nothing but shifting this function or shifting this arrow towards the left. Then we have 0, 2, 4. Arrow changes position from 0 to minus 1. Then we have Hn or impulse response equal to Sn nothing but 2, 4 minus 0, 2, 0, 2, 4. Arrow at the position of 0. If we minus them, then 2 minus 0 equal to 2, 4 minus 2 equal to 2 also. Then here 0 minus 4 equal to minus 4. This is the impulse response. Therefore, the impulse response Hn equal to, we have arrow at this position 0, 2, 2 minus 4. And now we have input and we have impulse response. Then we know from the tabular method we have easiest method is tabular. From that we find their convolution between the impulse and the input, and we have here the action from that side and Hn at that side. Okay, our input is 1, 3, and our impulse response is 2, 2, and minus 4. If you multiply them, then 1 multiplied with 2 is 2, here also 2, and minus 4. Then 3 multiplied with 2 is 6, and minus 12. Okay, then we separate that and combine from this and this and add this, then our output yn is nothing but hn convolved with xn is nothing but 2 comma 6 plus 2 equal to 8 comma 6 minus 4 equal to 2 and minus 12, which is output of the system. This question can be solved by different method. Method number 2, it can be solved by second method. It is method number 1 and this is method number 2. Here impulse step response is given as Sn equal to 2 comma 4 and input xn equal to given as 1 comma 3. When we draw it at the 0 position 1 and at 1 position magnitude become 3. This is the action 0 and 1. We have already discussed that this signal action can be represented by unit step signal. Then this signal become first unit step with the help of unit step. This 1 here, it means their weight is 1 and this is 1 represent here unit step un and plus their difference 3 minus 1 is 2, then it become 2 minus 1 and minus 1 from this position, okay, and minus 1, and after that from the second position it becomes 0. Therefore the total addition is 3, therefore we have to minus 3 u at the position from minus 2. Okay, this equation we have the input is represented by un plus 2 u n minus 1 minus 3 u minus 2, and we from the question we have that if un is applied to the system, then output is Sn, which is nothing but 2 comma 4. Okay, un we have un output of this, and when second input when un minus 1 means delayed input is applied to the system, then the output is also delayed with the same function. Then output become minus 1 is shifted towards left, arrow shifted towards left and the position shifted right. Okay, then 0 to 4. Okay, and here the 2 is multiplied there, therefore 2 plus 2, and this is multiplied with 2. So multiply with 2, then output become 0 and 4 on 8. Okay, the third u n minus 2, when we apply to the input, then the step response is also shifted with 2 shift function. Therefore the output is 0 comma 0 2 comma 4, and here the multiply with minus 3. Okay, then minus 3. Okay, then multiply with minus 3, therefore the output become 0 at 0th position 0, and minus 3 multiply with 2 is nothing but minus 6, and minus 4 is multiplied with 3 is minus 12. Okay, then our final step is to add all the signal. Therefore as we know that input xn is equal to where okay un plus 2u n minus 1 and minus 3u and minus 2. Okay, when we apply to the system, then output is yn. Therefore this also when we applied input step, then output is 2, 4 plus. If we apply this signal, then output is 0, 4, 8, and if we apply this signal, then output is 0, 0, minus 6, minus 12. And if we add all the signal with their respective position, then 0, 2, 0, 0, and this become 2, 4 plus 4 plus 0, it become 8, and here is nothing, then 8, minus 6 equal to 2, then 0 minus 12 equal to 12. It is yn of the system. As we compare with both the method, then the output is same, yn equal to 282 minus 12. Then here also yn equal to 282 minus 12. We have two methods, method number 1 and method number 2. This is your choice which method you have opt in the examination. Both are same and equal marking available here. In the next question, we have to evaluate the step response of the LTI system, where the impulse response is given by Hn and Ht. There is 4 type of question, 4 different question, one for discrete time and one for the continuous time. Here, from first, the impulse response of the system Hn is given by minus 1 by 2 and u n. Okay, then the question asking for step response of the system, and we know that the step response Hn equal to summation, we are moving from minus infinite to n hk. Okay, then hk is given here, n hk is given here minus 1 by 2 n un, then it become minus 1 by 2 to the power k and uk. The uk is unit step and it will change their limit from 0 to n. Okay, then the summation become k is moving from 0 to n minus 1 upon 2 to the power k, and we know the formula for summation till nth term equal to 1 minus 1 a is here 1 by 2 to the power n plus 1 divided by 1 minus a, where a is minus 1 by 2. It become 1 minus 1 minus is common here, then plus 1 by 2, and the limit become 1 by 2 to the power n, and divided by, when we open this bracket, then 2 plus 1 is equal to 3 divided by 2. Then this summation become 2 by 3 plus 1 by 3 to the power 1 by 3 minus 1 by 2 to the power n. Okay, now moving towards the next question, question number B. Question number B is here, Hn equal to del n impulse response minus del n minus 2, and we know that the Sn equal to summation k moving from minus infinite to n hk, where hk is del n minus del n minus 2. Okay, and when we open this bracket, then we have summation k minus infinite to n del n and minus summation k minus infinite to n u n minus 2, sorry, k. And we know that the summation of del n or del k become unit step, then it become un, and this become minus u n minus 2. Question number C, for continuous time, question is ht equal to impulse response ht equal to minus mod of t. Okay, then step response ht is nothing but the integral minus infinite to t h tau d tau. Now put this value ht, then ht equal to e to the power minus mod of t, then it become minus mod of tau d tau, and we integrate it in two partial value from minus infinite to 0. It become for minus term it become negative, and negative positive tau d tau. Okay, and then for the case where t greater than 0, then it become positive, then positive means e to the power minus tau from 0 to t d tau. When we integrate it or differentiate it, it become e to the power tau minus infinite to 0 plus e to the power minus tau divided by minus 1 from 0 to t. When we put it, e to the power minus infinite minus e to the power e to the power 0. Okay, then first limit we have put first, then e to the power 0 minus infinite, then minus this one, and put this value e to the power minus t and minus e to the power 0, and this become 0, and e to the power 0 become 1, and this also become 1, and minus e to the power minus t. Therefore the overall value is 2 e to the power minus t. This is our answer. Question number D, in the last section, the impulse response ht equal to 1 upon 4 ut minus 4 minus ut minus 4. Okay, then step response st equal to impulse integral minus t to t and 1 by 4 uk minus uk minus 4 d tau d tau. When we open and integrate it, then it become 1 by 4 minus infinite to t u tau d tau 1 completed. And this question, okay, this question is for overall integral, then it is overall. Okay, then overall common 1 by 4 and minus infinite to infinite infinite to t u tau minus 4 d tau, integral close. Okay, then we know that when we integrate ut or in step signal, then it become ramp signal. Then the 1 by 4 and integral of ut from minus infinite to t, it become r ramp signal r t, and minus this signal become same and shifted with the same shift delay, then it become r t minus 4. This is our step response of the signal.